one of the most common items found in toy stores throughout the globe. However, who knew there is complex chemistry behind these seemingly simple soap bubbles? Today, we will be conducting experiments and exploring the chemistry behind bubbles.
Let's make bubbles!
Water is composed of 2 hydrogens and 1 oxygen. The surface of the water is nonpolar, which attract the polar soap molecules.
Glycerin is composed of carbon, hydrogen, and hydroxide. It is sweet and non-toxic. It is also used in the food as a food preservative or as a sweetener. In bubbles, it strengthens the connections between the soap molecules, thus making the bubbles last longer. Corn syrup is similar to glycerin in that it strengthens the bonds between the soap molecules. However, corn syrup is supposed to be more effective than the glycerin.
Soap molecules are made up of chains of atoms of carbon and hydrogen. While the chain as a whole is nonpolar, the 2 ends of the chain are different. One end of this chain is hydrophobic, meaning that it dislikes water. The other end of this chain is hydrophilic, meaning that it is attracted to water. When soap and water mix, the soap molecules form clusters called micelles. These clusters are shaped so that the hydrophobic ends are in the middle of the cluster and the hydrophilic ends are on the outside. These micelles then move so that their polar ends are in the water and the nonpolar ends are located on the surface of the water. The soap molecules on the surface are critical to the formation of soap bubbles. When a bubble wand is placed in the solution and then removed, a soapy film is transferred to the wand. The film consists of 2 soap molecules with a water molecule in between them. The hydrophobic ends flock to the surface to avoid the water, and this creates a separation from the water molecules, which in turn lowers the surface tension, allowing bubbles to form. The relatively thick soap film can withstand punctures by small objects, such as hands, so long as these objects are coated in soap solution or water. While our lab did not require wearing safety attire, it is always good to be prepared and wear proper safety gear when performing a lab. To make glow-in-the-dark bubbles, we used the same recipe as we did for the regular bubbles, except we broke a highlighter and added the inside tubing to the mixture. The glow-in-the-dark bubble solution appeared lime green under normal light. However, under black light, it looked bluish. A black light bulb was installed to show the characteristics of the glowing bubbles. Fluorescence is the concept of glowing, which occurs when something absorbs light and then emits this light with less energy. The black light bulb provides high energy light, which is invisible to us, and the chemicals in the highlighter ink take in this light and send it back out as yellow light, which we can see.